still chapter 3, so our last chapter of our section for our section exam. So factoring applications lesson 1, so we're going to review factoring. So factoring involves the sum or difference of monomials as a product of polynomials, so it's just factoring down addition and subtraction of trinomials to binomials, okay, of multiplication. So we have these are our methods we're going to be focusing on for this section. Factoring by taking out common factor, which is called GCF, greatest common factor. Factoring by difference of squares, that's going to be when you have a binomial that's perfect squares of both of them. We'll talk about that. Factoring by inspection, that's what we did in the warm-up. And then factoring by grouping. Okay, grouping is kind of a form of our decomposition that we'll move to, but that's where we're going. Okay, so this section here says factor each polynomial by removing the greatest common factor. So greatest common factor is just finding out what they have in common. So for A, they have a 5 in common and an x squared in common. When you're pulling stuff out, you're dividing it. So 15 divided by 5 is a 3. I had x3, I took 2 of them out, I have 1x left. See how a 5x squared here? That's what I took out. So 1, I took it out, but a 1, not a 0, there's a 1 left. So if you distribute it back, it would be the same thing. Any questions on that? Okay. Part B, what do they have in common? 4. Yep, just a 4, because the last piece there's no p. So just a 4, so 2p cubed minus p squared minus 1. That's all you can do there. Now this one here is kind of weird, and they're setting you up for factoring by grouping. What does C have in common? They both have a what? A y plus 2. See that? They both have a y plus 2. So we can pull this out. And we do that, we're left with 3y minus 9. Do we see that? Like the 3y minus 3y minus 9 got pushed together. Does 3y minus 9 have something in common? 3, yeah, so we can go and pull a 3 out as well. That 3 that you pull out, guys, it can go here and go on the outside, but they're going to put it out here. Okay, so the 3 came out over here. Y minus 3 is what's left. So I took a 3 out of this spot right here, if you're wondering what happened. They both have a 3 in common. All right, any questions there? Okay, so now we're going to come into the basics of difference of squares. A difference of squares is when you have a difference, so difference means minus sign, okay, and of perfect squares. So like for example, is x squared a perfect square? Yeah, it's x squared. It's 81. Yes, this is a difference of squares. And to do them, it's kind of an easy pattern. It's x plus the square root of the other one, x minus, it's the square root plus the square root minus of both of them. So x plus 9, x minus 9. Now, this should make a little bit of sense to you because of what we did with radicals, right? This is x squared minus 81, so what's it missing in terms of terms? It's missing a middle term. The middle term's canceled, right? X plus 9, x minus 9 are conjugates of each other, right? And so these are the patterns of when you have conjugate multiplication. Difference of squares are. So there's no middle. That's why there's only 2 terms. The third term got canceled. So whenever you have difference of squares, that's what's happening, okay? Just thinking in terms of our conversation about conjugates. So here is 25 perfect square, a squared, and 49. All perfect squares, we're good to go. 5a plus 7, 5a minus 7. The order does not matter of addition or minus. You can put the minus first or minus second. It doesn't matter. C. Can't do. Good. If you jump the gun on it, that's a plus sign. It's a difference. Not able. So can't do that one. Now D, there's a couple layers to D here, because is 16 a perfect square? And then t squared is a 64. Yes, but does 16 and 64 have a GCF? Yeah, they do. So you can actually pull a 16 out first. Okay, or is an 8 out first? No, it's 16, right? 16 out first, yeah. Pull a 16 out. That gives you t squared minus 4. T squared minus 4 still is a difference of squares. Okay, yeah, the t squared and a 4. So now it's 16 times t plus 2, t minus 2. And then we're going to go down and do a couple of ones like we did in the warm-up here. For example 3. Then we're just going to talk about the flow chart of it, and one more example set and we'll be done. So like it's a short day today. Okay. All right, so where possible, factor the following trinomials by inspection. Okay, so again, you're looking, here's what you can do. I'll give you guys some sheet on Monday for this. They're just little X sheets. And what you do is you put the end thing on the top, you put the middle on the bottom, and you just say 2 multiples of 30 that add up to 11. And so it just kind of helps you organize your thoughts. Okay, so if you don't like it, it's fine. It's just a strategy to organize your thoughts. So then you would just say, okay, a plus 6, a plus 5. Does that make sense? Yes. Thanks, Adam. Just by myself up here. It's a man and his thoughts. Okay, negative 30. So if you want to do the x again, you can. So like negative 30. Difference of 1, so it's a negative 1 there. So factors of 30 that are 1 apart would be 6 and 5. Since that's negative, the bigger number is negative, because negative 6 plus 5 is negative 1 in that case. So b minus 6, b plus 5. Is that factor? Okay, 48. So we have 48 and 1. 24 and 2, 16 and 3, 12 and 4, 8 and 6. None of those are 4 apart. So this one's not factorable. A little bit of a tricky one there. Not factorable. Okay, for D, what are we going to do first? Yeah, take a 3 and an x out, right? So take a 3x out, so we're left with x squared minus 7x plus 12. And now we're going to factor x squared minus 7x plus 12. Since you got a plus 12, that means they're the same sign. The minus 7 means they're both negative. So it's going to be 3x times x minus 3, x minus 4. Okay. Any questions on that? Perfect. Okay, so this one sets you up for decomposition. Factoring by grouping doesn't happen very often on its own, okay, but we do it every time for factoring by decomposition. Decomposition, you probably don't know what that is. That's when you factor when you have a 3a squared here, but you can't pull the 3 out, okay, because you have to be able to factor that as well. So we'll do that as a lesson, but this is just a part of it. So this right here, by grouping, you simply just group in pairs of 2, and then you GCF each spot. So you group in pairs of 2, and you GCF each spot. So this right here, they both have an x in common. So it's x times x minus 5. This right here, they have a 2 in common. They have x minus 5. Now to our part up there with the y plus 3, what do they have in common there? Or y plus 2 it was. They have an x minus 5. So what happens is this x minus 5 comes out as a single x minus 5. And then look, the x plus 2 there gets pushed together. Do we see that? So this part right here came out together, and then the x plus 2 got pushed together. Okay. All right, 6y squared plus 9y. We're going to pull out a 3y there. Gives me 2y plus 3. And then see how that's a 2y plus 3 there? Well, we're just going to pretend a 1 came out just so that we have something sitting there so we see it. 2y plus 3 is on both pieces, so that's what we can pull out. And the 3y plus 1 gets pushed together. So there's your factor. Like simplifying, guys, factoring is a form of simplifying in the sense that if I FOILed out 2y plus 3 plus 3y plus 1, I would get that top part there. So you would get that. Okay? All right. Just going to go through the flow chart, one more example set, and then you guys will be free here. So guidelines for factoring a polynomial expression. So this is kind of your guidelines. First thing is look for GCF. Okay? Look for GCF first. If it's a binomial, think about difference of squares because binomials or difference of squares come in binomial form. If there's trinomial, try to do inspection. If it's the trinomial expression that's bigger than we can do, we do decomp, but you guys don't know that yet. Okay, that's the next lesson. And if there's polynomial with 4 terms, look for grouping. So it's just kind of your flow chart here. So the very first thing, always look for GCF. Are you 2 terms, 3 terms, or 4 terms? If you're 2 terms, look for difference of squares. If you're 4 terms, try grouping. If you're 3, there's 2 options. There's going to be when A is 1, which we did today. That's inspection. And then when A is not 1, which is the next lesson of decomposition. So this is pretty much the only thing you can do for factoring. Okay? All right, last little piece here. I put them backwards on you now. 36 minus 9x squared. So on your flow chart, where do we flow to? Binomials, difference of squares. Is this a difference of squares? Yes, 36 and 9x squared are all squares. So 6 plus 3x, 6 minus 3x. Oh yeah, definitely, you're right. We can take a 3 out of both of them. We could have took a 9 out early. So yep, sorry. Take a 3 out of both of them. So if you take a 3 out of both of them, they both turn into 2 plus x, 2 minus x, and those 3's become a 9 with multiplication. Yeah, so that means we could have took out 9 early, so I forgot the GCF, dang it. Okay. This one's just written backwards, so hopefully you don't mess up too much with it. But one thing I like to do with these is that, see how it's a minus x squared? I know it has to do this. Right? Negative x times positive x, negative x squared. That's the only thing it can be. So now think about what are factors of 28 that are 3 apart? 7 and 4. 7 times 4 is 28, and those are 3 apart. Now it's tricky here. What goes where? 4 has to be. Correct. The 4 has to be negative, so that it goes, though, here. Why? Because the negative x hits it. See this 7 here? The 7's not negative. The 7's positive. Okay? So that's what it'd be. 7 minus x, 4 plus x there. The backwards ones are kind of tricky. Got to change your thinking a little bit, but that's it.